Hello everyone, welcome to today's video. In today's video, we'll be discussing about molecular mass, equivalent weight. So let's begin the video without any delay. Now when I speak about the term molecules, what exactly is molecule? I've told you in the previous video when we're discussing Avogadro hypothesis. So you all know what's a molecule, right? Now, if I write molecule, okay, we can classify it into two parts, very simple parts. What is that? We can be writing it as atomic, or we can write it as heteroatomic. Clear? Molecule will contain atom, that much you all know. So we can write it as homoatomic or heteroatomic. Now what exactly is homoatomic? That means this word homo, you have learnt in biology a term called homozygous, and that was a heterozygous or heterozygous. This term means same, this term means different. So same applies over here. Okay. So what's a homoatomic? That means same type of atom. Clear? Same type of what? Atom. समझ गए? Same type of atom. यहाँ आते हैं heteroatomic. That means different type of atom. Now how many different types are not specified, but different types of atoms, which can be two or more. Simple. So here same type of atoms are present, here different types of atoms are present. Then it is a heteroatomic. Okay. Now let us move on to one by one. First let us come to homoatomic. Okay. This is homoatomic. Okay. That means same type of atoms. First one, monoatomic. Monoatomic means one atom in one molecule. Who are they? Inert gases. Am I correct or wrong? Inert gases, they have only one atom in their molecules. So inert gases is going to be the answer over here. This is monoatomic. Now if I mention diatomic, then what will be the answer? You all know Mr. Chlorine is there, nitrogen is there, oxygen is there. Okay. Okay, when you are there, I'm not writing all. Next comes triatomic. Triatomic means three atoms in one molecule. We have is ozone, O3. Then we have is polyatomic. Okay, polyatomic. Polyatomic. Poly means more than two. This also falls under polyatomic. Okay. Now we will be reading polyatomic is tetra and is octa. That means octatomic and tetraatomic. Who is tetra? Phosphorus is tetra, sulfur is octa. So all these are homoatomic. As you can see, they are composed of only one type of atom, right? They are not composed of different types of atoms. So we all will be saying this as a homoatomic, monoatomic element, this homoatomic diatomic element, this homoatomic triatomic element, this homoatomic tetraatomic element, this homoatomic octatomic element is sulfur. Clear? So this was all discussion about homoatomic. Now we will be moving on to the another category, that is heteroatomic. Heteroatomic. Okay, let me erase this part. Okay, now let's discuss monoatomic. What is monoatomic, heteroatomic? Is it even possible? It's not possible only. First of all, not possible. Why it's not possible? I write, suppose let us take a basic example. I am writing HCl. Here also minimum 2 has to be there. Minimum 2 has to be there. 1 is possible. In case of heteroatomic, never possible. If there is only 1, then there has to be like this. Then it will no more be a heteroatomic, it will be a homoatomic. So heteroatomic, monoatomic is not possible. Clear? Homoatomic, monoatomic is not possible. So I cannot write any example here. Next is diatomic. This is possible. Just now I wrote HCl is there, HBr is there. All these are having 2 atoms in its molecule. You check it. One molecule of HCl is having what? 1 atom of hydrogen and 1 atom of chlorine. We have shown that using Avogadro hypothesis. Now coming to triatomic. You have is your water. Many other compounds are there. This is water. You have is your NO2, SO2. All these are having 3 each. 2 plus 1, 2 plus 1, 2 plus 1. Clear? Now polyatomic also you are having many. Okay, I am not classifying it as like tetra or all that because you are having many. Polyatomic falls under this category. If I write CCl4, it is having 5 penta. If I write ammonia, it is tetra. So there are a lot of categories like this. So I am not mentioning everything. Okay. Now if you write many formulas are done, like you write oleum, so it will become again something. So it's all category is polyatomic. So monoatomic, heteroatomic, it is not possible. Heteroatomic, diatomic is this. Heteroatomic, triatomic is this. Heteroatomic, polyatomic is this. Examples are needed. These are generally not asked in the question. Okay. Done. This was all to discuss from categorization of molecules. Okay. Now let's move on to atomic mass, molecular mass and all those. Okay. Now how will you determine an atomic mass? That is in the later part, not now. What exactly is atomic mass? You all know that an atomic mass is the weight of one atom. It's the mass of one atom, right? One atom of an element. Now how will we determine that? Because the atom is very small. How will we determine that? There was a scientist called Stanislav. Okay, Stanislav. What did he say? He took hydrogen as the standard substance. Okay, Stanislav Cannizzaro probably was his full name. I don't exactly remember. Okay, one formula you need to remember: relative molecular mass. Here we are dealing with atomic mass. So let us take right now atomic mass. Relative atomic mass will be equal to atom of weight of one atom of substance. What did I write? Weight of one atom of substance divided by weight of one atom of standard substance. That is the substance with whom reference has to be made. That is called the standard substance. So with respect to the standard substance, we are going to state the molecular mass. It's relative molecular mass. To understand? Clear? Understood? Okay. Now here, this standard substance was taken as hydrogen by Stanislav. Okay. It was seen that it's fine, but in some cases fluctuations were arriving, so it was again discarded. Followingly, it was taken oxygen. Again, it was found that at some cases oxygen is not varied properly. Then again, oxygen was also not taken. Then came the final one, that is C12. C12 is the most stable isotope of carbon, and this was done. This was taken as the standard substance for relative atomic mass. Is it understood? Clear? The International Union of Chemists took this as the standard substance. It is found more or less it's okay with everyone. So we are using it till date. Clear? So now next we will modify the definition. Modify the definition of relative atomic mass. Initially the definition was that relative atomic mass of an element is the weight of one atom of substance. This is weight of one atom of substance. You can write like relative atomic mass is ratio of this, but do not write it a very lame one. What will you write is relative atomic mass of a substance means one atom of an element is how much times heavier than one atom of the standard substance. Hydrogen over here. Okay. Next it was modified. It was modified. Relative atomic mass of a substance is the number of times one atom of a substance is heavier than 1 by 12 the mass of carbon 12 atom. Clear? So when we will be doing with the carbon 12, then here it will be weight of clear? Understood? This scale is called atomic mass unit scale. Okay, this is 1. Okay, always you cannot take more than 1, otherwise it will be coming different. Okay, 1 by 12 of 1 C12 atoms mass is divided. Okay, that is the denominator for here. Clear? This scale is called atomic mass unit scale. What is it told? Atomic mass unit scale. Okay, and when you are writing the relative atomic mass, you write it in the form of AMU. We have done that, I know, right? This is atomic mass unit, AMU. Clear? Now gradually we are leaving this concept of AMU, we are writing in generally in grams. Generally I am talking about, okay, but this concept is still existing. Okay, so this is atomic mass unit scale. Done? Over? Okay. Now this was relative atomic mass. Now if I change the word relative atomic mass to gram atomic mass, what difference would you find out? Gram atomic mass. I have changed the word gram. Gram atomic mass. Previously it was relative. What is gram atomic mass? Achha, what is atomic mass first of all? I have already discussed what is atomic mass. Here the atomic mass of the element will be represented in grams. Clear? In grams. So what is going to be the definition for this gram atomic mass? Suppose you have x gram of sodium. Atomic mass of sodium is 23. Fine. You have is x gram. This x gram corresponds to how much? That will be the gram atomic mass. Okay. So this quantity is represented in which unit? Gram. Gram. So your gram atomic mass has to be in gram. So what exactly is this gram atomic mass? It is the amount. Do not write amount, it will be sounding very good. It is the quantity of an element. Clear? Quantity of an element. Quantity of an element whose weight in grams will be numerically equal to the atomic mass of that element. Clear? It is the quantity of the element whose weight in gram will be numerically equal to the atomic mass of that element. So this x gram, if it is numerically equal to 23 AMU, then we will be saying 23 gram is the gram atomic mass of sodium. Did you understand? So gram atomic mass means the quantity of the element whose weight in gram में उसका weight numerically equal to the atomic mass, it is in atomic mass unit. If this is equal, then we will be saying this as the gram atomic mass of sodium. Clear or not clear? Understood gram atomic mass? Next comes gram atom. Gram atom. This gram atom means weight, something weight will be given divided by gram atomic weight. Clear? Understood? A weight will be given divided by gram atomic weight. Now if this is in gram, then this has to be in gram. Logically also you can find out. You cannot divide two terms and not in same unit. Can you? If two units are different, you cannot divide them. So your unit has to be same. So you have to also see here. Clear? So here below is gram. The numerator also has to be in gram. So weight in gram divided by gram atomic weight or gram atomic mass. Clear? Understood? Understood? Now we will be changing the words. Just changing the word. Instead of this gram atom, we write gram molecule. What will it be? Weight of molecule divided by gram molecular weight. Nothing is changing. Everything is same. Only word is changing. Okay? Gram molecular weight, relative molecular mass, is the sum of all the molecules, sum of all the elements in one molecule. You already all know that. Okay? Here gram molecule will be weight in gram of one, weight in gram whatever is given. divided by gram molecular weight. Clear? Okay, we'll discuss molecular weight again later on. Now we are going to discuss a very important thing. So please hear, okay? That is chemical equivalent or equivalent weight. Chemical equivalent. Here there is a different topic. Equivalent weight. We have discussed about molecular weight. We have discussed about atomic weight. Then what exactly is different about equivalent weight? See, equivalent, what do we use? When do we use this term? In maths you have a similarity, similar triangle. Two triangles are similar but they are not equal. Two triangles are similar. If two triangles are equal, they will become congruent. We are not discussing congruent, we are discussing similar. Same here. If we write equal, then it's different. That means both the masses are equal. But if the two masses are equivalent, then that necessarily does not be it is equal. So this equivalent means in some respect it is equal to it. Some respect, not exactly equal to it. Clear? We can say it in terms of it, equivalent to it. This is equivalent weight. How will you define equivalent weight? Equivalent weight is the number of parts. Understand first. A substance is there, let us take X. How many parts by mass? How many parts by mass? Remember, I have talked about this term parts by mass in the law of reciprocal proportion. I have told you how many parts by mass oxygen is going to combine. Parts by mass. Okay. So how many parts by mass of the substance, of this substance X will be combining or displacing? If combining is happening, displacement can also happen. So parts by mass, either it is combining or it is displacing. So again I am discussing from the first. Is the equivalent weight is the amount of part by mass of a substance that combines or displaces. These two things are happening either directly or indirectly. Again another topic, directly or indirectly. Clear? Equivalent weight is the amount of number of parts by mass of the given substance combining or displacing directly or indirectly. What they are displacing? Either they are displacing 1.008 parts by mass of hydrogen or 16 parts by mass, okay, I am writing in short, parts by mass of oxygen or 35.5 parts by mass of chlorine. Clear or not clear? Clear or not clear? Three things I have given. One is 1.008 parts by mass of H2. Oh sorry, this is not going to be 16. Sorry. This is going to be 8. Or 8 parts by mass of oxygen or 35.5 parts by mass of chlorine. If this, either of this is happening, then it is the equivalent weight found. You have to find the equivalent weight by this. There are a lot of methods which we will discuss at the end of the chapter, not now. Okay? Did you understand the definition of equivalent weight? So equivalent weight is defined as the number of parts by mass of this given substance X which combines or displaces directly or indirectly these three things. Either of these three things, not all these three things. Clear? Either of these three things. Understood? It's the number of parts by mass combining or displacing directly or indirectly either of these three, 1.008 of parts by mass of hydrogen or 8 parts by mass of oxygen or 35.5 parts by mass of chlorine. Either of these three things is happening, then this is equivalent weight. Clear? Understood? Let us proceed. Equivalent weight determination. No, we are not doing that. What you are thinking, that is how to calculate equivalent weight by oxide formation method. All that, no, that is not there. That is there, but not now. Later on in the chapter. Okay. Now, how will you calculate equivalent for simple things? Very simple ones, like equivalent weight of an element. If you have to calculate the equivalent weight of an element, first step we are taking is an element. If you have to calculate element, then what will you do? Then what you are going to do? You are going to take the atomic mass of that element. Atomic mass taken divided by the valency. That will be your equivalent weight. Clear? We are not yet applying to reactions, so be careful. Okay, this is not being applied to reactions. Just we are discussing. We are not applying to reactions. Reaction later on will apply. Not now. Hold on. Okay. So element, atomic mass divided by valency. Any element you take, let's take sodium. What is atomic mass? 23. What is the valency 1? Equivalent weight is 23. Clear? Understood? 23 is the equivalent mass. So element, if it is there, atomic mass by valency. Clear? Atomic mass divided by valency. If it is a element. Understood? Clear? Now your question can arise. What question can arise? भैया ये वैलेंसी है, इसका अगर वेरिएबल वैलेंसी हो गया तो क्या करें? यहाँ तो वैलेंसी एक है, वैलेंसी is fixed 1. If valency differs, then suppose this element is not this element is, let us take, is copper. If in this case it is copper, then what will happen? Copper has 2 and 1 valency. What will we do? Then individually you have to find out. We do not have any other way. Suppose copper sulfate salt, here it is 2 positive, you know, valency. This is charge, oxygen state number, sorry. Valency is 2 over here. So what is the mass? 63.6 divided by 2. Calculate. If it is 1, yani cuprous salt, that will be 63.6 by 1. So you have to calculate it individually because you don't have any other option. Clear? Simple thing. So ये valency अगर variable हो गया तो individually salts में calculate करना होता है. Okay. दिया गया element कौन? Who arrives next? Next arrives is normal salt. अभी ये वो नॉर्मल एबनॉर्मल की बात नहीं है, ये नॉर्मल सॉल्ट है यानी न्यूट्रल सॉल्ट है जिसमें कोई हाइड्रोनियम भी नहीं है, कोई हाइड्रोक्सिल भी नहीं है, तो इट्स अ न्यूट्रल सॉल्ट, राइट? नॉर्मल सॉल्ट मीन्स न्यूट्रल सॉल्ट. नाउ इट इज अ न्यूट्रल सॉल्ट, देन हाउ विल बी डिटरमाइंड? In this case we will be taking is the formula mass. Remember the formula because it is very important. Formula mass of this salt divided by total charge. Understand? Total charge on cationic part. Plus V means positive one. So this is cation. Okay. This is cation. Did you understand? Formula mass you have taken. Total charge on cation you will be taking. Clear? Formula mass divided by total charge on the cation. Take an example. Hold on. NaCl. What have we taken? NaCl. Okay. What is the total mass? 23 plus 35.5. 58.5. 58.5. What is the total charge on this part? This is plus 1. This is minus 1. Plus 1. Plus 2 will not ignore only. I mean will ignore. I mean will not take. Will not ignore. It's very wrong English. Sorry. Okay. Done. So 58.5 is the relative molecular mass. Equivalent weight. Clear? This is the formula mass. This divided by the charge on cationic part. Answer is here. Understood? So cationic part, what is the total charge? You will be writing below, and up will be the formula mass. Add up everything now. What is the difference? Clear? Understood? Now if you have discussed about neutral salt, then why not about acid salt? Discuss about acid salt also. Let's discuss about acid salt. Stop this acid salt. Normal salt does not contain any replaceable hydrogen ion or OH minus ion. But acid salt contains one replaceable hydrogen, not one, maybe any. Okay, this is acid salt. That means one replaceable hydrogen ion has to come, like NaHSO4. This replaceable hydrogen ion. Clear? So here also formula mass, but this one will differ. What we will be writing instead of this? Number of replaceable H atoms. Clear? Number of replaceable hydrogen atoms. Clear? How many hydrogen atoms are present here in NaHSO4? 1. So here we will write 1. Calculate the formula mass and write. Clear? Clear? How much is the formula mass? 23 plus 1, 24. 24 plus 32. And 64. 120. This will be 120 divided by 1. That will be 1. Clear? 120 divided by 1 because 1 hydrogen ion is present. So 120 by 1 is 120. Clear? Understood? So this is the equivalent weight. So if it is acid salt, then what we have done? Formula mass divided by how many replaceable hydrogen ions or hydrogen atoms are present. Clear? Atoms only will be better. Don't write ions. Okay, clear? This is acid salt. How will you calculate equivalent acid salt? Formula mass divided by number of replaceable hydrogen atoms present. Done? Clear? Any problem? Okay. Next, acid. If it's an acid, then how will you do it? If it's an acid, then what will you do? Molecular mass, you have acids divided by basicity. Acid has basicity, base has acidity, you all know that. So this is basicity of that acid. Clear? What is the molecular mass of that acid divided by the basicity of that acid will give you the equivalent weight of that acid. Example, let's take, it's sulfuric acid, 98 divided by basicity is 2, so it's 49. Clear? Sulfuric acid is 98, basicity is 2 because H2SO4, 2H are linked to oxygen, so that will be 45. Clear? Basicity is 2, dibasic acid. Clear? Now what is basicity? What is basicity? Number of hydronium ion produced upon ionization in water per molecule. Clear? That is basicity. Acidity is the number of hydroxyl ions produced by per mole ionization. Okay. Okay. Base, should I write the base or base you can write? I am not writing the base. Okay. Base will be same thing, molecular mass divided by acidity. Okay. Base will be acidity, acid will be basicity. Any question, any doubt on this? Okay, next is an important one. Next we are going to calculate equivalent weight of oxidant or reductant. Clear? Oxidant or reductant. In your book you will get a lot of example. I am not going to show everyone. I am going to show everything. I will be showing 2 examples. Okay. Okay. First example let's take is a very good oxidizing agent, KMNO4. This person's equivalent weight. Now you cannot randomly find because this depends on the nature of the medium you are taking. This depends on the nature of the medium you have taken. First let's discuss step by step. Basic medium. If the medium you have taken is a basic medium, then what will happen? MnO4 minus will gain 1 electron and it will turn into MnO4 2 minus. Clear? From here, how will you determine the equivalent weight? Equivalent weight determination is again formula mass. Above formula mass, molecular mass, all that thing will remain same. Changes will happen in the denominator. So molecular mass of this person will be calculating. Okay, how much is the molecular mass? Let me calculate. One minute, let me calculate the molecular mass. Forgot. 158. Okay, this is 158. So what is the equivalent weight? I'm writing an equivalent weight. Okay, this is 158. How many electrons lost or gain? Here lost. Lost. This is lost or gain? Lost or gain? This is lost or gain? Lost. How many electrons lost? 1 electron. So it's 158. I was just trying to confuse you. It's lost or gain? Lost. That is why the charges become 2. Clear? Clear? Okay. So this is 158. Okay. That is why I was also thinking. This is gaining, not losing. If this would have been losing this, then this charge is no more there. It will become MnO4. That is nothing. This is actually plus charge. Okay, that was my mistake. Okay, anyways. Now coming to neutral medium. We have basic on one end of the pH meter. Basic, medium, neutral, then acidic. So I am also coming in that order. Neutral. If the medium is a neutral one, then what will happen is MnO4 minus plus 8 hydronium ion, hydrogen ion plus 5 electron will give you MnO2. Oh, 1 minute. This was not for this. Neutral medium you have is MnO4 minus. 3 cases are there. One is basic, neutral, acidic. This is neutral case. In the neutral case, you have is MnO4 minus plus 2 water molecule plus 3 electron, which will give you MnO2. Clear? Plus 4 OH minus. Clear? Understood? What I was writing was for acidic medium. Never mind. This is neutral medium. MnO4 minus plus 2 water plus 3 electron forms MnO2 plus 4OH. Now let's check out the equivalent weight, because we are not bothered with the equation. We are bothered with the equivalent weight. It depends on the neutral medium. Okay, actually, how many electron? 3. So 158 upon 3. Clear? What is the answer? 158 divided by 3. 52.6. Okay. So when your neutral medium C changed, how many electron lost? 3. Answer is 3 divided by 3. Clear? So you have to check it out, how many electron transfer is going on. Checking the electron transfer and putting it in the denominator. That will be the most important thing. Okay. Now last one is in case of basic medium. Basic medium, this MnO4 minus, what happens is it takes in 8 positive plus 5 electron, okay, to give Mn2 positive plus how many? 4 into 8, that means 4 water. Clear? 4 water. So here the equivalent weight becomes 158 divided by 5. 158 divided by 5. 31.6. Clear? So here how many electron transfer? 5 electron. Previously 3 electron. Before that also 1 electron. So you can see it depends on the medium. So it depends on the medium. So medium is the most important thing over here. So you need to remember for what medium is what. Clear? Understood? Clear? Okay. Next. If this equivalent weight is expressed in grams, what is the thing? Again same thing. The mass that is expressed in gram, the quantity expressed in gram is equal to the equivalent weight of the substance is the gram equivalent weight. No problem. The quantity of a substance that is expressed in grams, which is equal to its equivalent weight, it is the gram equivalent weight. Clear or not clear? Okay. Okay. Okay, now check out. We had one equation, equivalent weight equal to atomic mass by valency. Did we have atomic mass by valency? So from there we can write atomic mass equal to equivalent weight into valency. This divided by this is equal to this. So if we put a word gram in front of this, here also we can put a gram. So that's also an equation. Okay, gram equivalent weight will be equal to gram atomic mass divided by valency. Clear? That also you can check it out. Equation is there, derived directly. Clear or not clear? Acha, molecular mass you already know. I have to say nothing about molecular mass. You already know what is a molecular mass. All definitions over there will change for atom to molecule. Clear? Okay. I am not going into details about molecular mass because you all already know that. Okay. Okay. Now let me short discuss about mole concept. I have already created a separate video for mole concept. So in mole concept we will be reading about what is mole. Okay, mole is the amount of substance which contains exactly the same number of chemical units as there in 12 gram C12 carbon atom. That we are going to check. Mole, 1 mole. What is 1 mole? We are going to check. What is molar volume? We are going to check. What is Avogadro number? We are going to check. Avogadro hypothesis discussed before already. Okay, molar volume we are going to check. What is molar mass? You are going to check. Molar mass. This is again a different term. What is molar mass? Mass of 1 mole. 1 mole of a substance, what is the mass is called a molar mass. Clear? Mass of 1 mole of a substance, it is called molar mass of that substance. Understood? Clear? Molar volume is the volume of 1 mole. 1 mole volume that occupies at STP, it is the molar volume which is fixed 22.4 liter. Clear? 22.4 liter. Then you have his formula mass. What is formula mass? Sum of atomic masses of all atoms are present in the chemical formula is formula mass. Clear? Then is lattice. Don't mix it up with lattice enthalpy. That's different. That's not here now. That's very much far away. Okay, that's lattice is what is the arrangement? Arrangement of the ions. You know, the arrangement of the ions in case of ionic compound is a definite. That is lattice. That is lattice. Clear? Understood? Any doubt? No doubt? Okay. Next we are going to do the determination. How will you determine the molecular mass? Actually it's a relative molecular mass. How will you determine the relative molecular mass? We have got certain methods to do so. So let's understand the methods. The first method is molar volume method. Clear? In molar volume method, you are going to apply is W by V into 22400. If you are going to apply this, we will be getting the molar volume. Clear? W by V. Understood? How did I get it? If the weight was initially W, W was the weight, volume was V. Okay, then V volume will have W gram weight. V volume will have W gram weight. Then how much will 22,400 cm cube have? W by V into this. There, now we'll say how did I write this equal to this? This is molecular mass. How did it equal to this? This particular thing is occupied by whom? Molar volume. This is molar volume, right? This is molar volume. That means this is occupied by 1 mole. What is 1 mole? 1 mole is a molecular mass. 1 mole of a substance equal to its molecular mass. We can say 1 mole of a substance is equal to the molecular mass of the substance. Clear or not clear? 1 mole of sodium means how much? 23 gram actually. Clear? So we can say this molar mass rather. That is not a problem. This is regular molecular mass. Instead of this, we are writing this. Clear or not clear? Numerical it is equal ना? That is the thing. ठीक है? Understood? हमने क्या किया? पहले किया वेट है W, वॉल्यूम है V, V ग्राम का वजन W ग्राम है. यहाँ 22,400 सेंटीमीटर क्यूब कितना हो गया? W by V इंटू 22,400. ये जो 22,400 सेंटीमीटर क्यूब है इसको हमने 1 मोल लिख दिया. 1 मोल को मोलिकुलर मास में ट्रांसफर कर दिया, तो इसको यहाँ बैठा दिया, इसको इक्वल टू ये है हमारा मेन इक्वेशन। क्लियर। अगर कोई कैलकुलेशन बाई चांस आ जाए तो ये फॉर्मूला लगाना है W/V इंटू 22,400। कोई डिस्क्रिप्शन एलाबोरेशन की जरूरत नहीं है, स्ट्रेट फॉरवर्ड फॉर्मूला लगाओ, काम करो। ठीक है, अंडरस्टूड। ओके, नेक्स्ट मेथड भी बहुत ही इजी मेथड है। नेक्स्ट मेथड है रेगनॉल्ट का मेथड। क्या है? रेगनॉल्ट का मेथड। व्हाट इज इट? रेगनॉल्ट्स मेथड। रेगनॉल्ट मेथड, ये भी ज़्यादा बड़ा नहीं है। रेगनॉल्ट्स मेथड। What did Regnault state? That molecular mass is equal to twice into vapor density. Very much true. How will you get vapor density? Vapor density is the mass of vapor. Mass of how much vapor? Mass of, let us take x centimeter cube of vapor of a substance at some temperature, let us take. Okay, at, let us take T degrees Celsius and P pressure. Okay, P atm pressure divided by mass of x centimeter cube of which gas? Hydrogen gas. Correct. So mass this of hydrogen gas at T degrees Celsius and P atm pressure. Take it out. अंडरस्टूड और नॉट अंडरस्टूड? चेक। रेगनॉल के मेथड में क्या किया? रेगनॉल ने कहा कि मॉलिक्यूलर मास है ट्वाइस वीडी। ठीक है, मान लिया। वीडी क्या है? मास ऑफ x सेंटीमीटर क्यूब ऑफ वेपर एट T डिग्री सेल्सियस एंड P एटमोस्फियर इज P प्रेशर। ठीक है, डिवाइड कर दिया उसको मास ऑफ x सेंटीमीटर क्यूब, x का वैल्यू सेम है, ऑफ हाइड्रोजन गैस एट T डिग्री सेल्सियस एंड P atm। सो ये जो कंडीशन है बदलेगा नहीं, बदल गया तो आंसर बदल जाएगा। ठीक है, तो यहाँ से वेपर डेंसिटी बदल दिया, 2 इंटू कर दो, ये बन जाएगा। ठीक है, ये कहा रेगनॉल्ट मेथड ने। ठीक है, दिस इज रेगनॉल्ट्स मेथड। अंडरस्टूड? ओके, नेक्स्ट मेथड इज डिफ्यूजन मेथड। नेक्स्ट मेथड इज डिफ्यूजन मेथड। विच मेथड? डिफ्यूजन मेथड। Okay, diffusion method. What is diffusion? What is diffusion? Free movement of molecules from higher to lower concentration when they are kept in contact. No, that is biology. We are discussing which subject? Chemistry. What is the definition of chemistry? Study of rasas. So we are not dealing with the study of water molecules, are we? No, we are not reading absorption. Are we reading absorption? Then why will we be doing that? Clear? What is diffusion in chemistry? Diffusion is the intermixing. Diffusion is the intermixing of two gases. Can do one more gas. Clear? Intermixing of two or more gases against gravity. Against gravity. Clear? Two or more gases, if they are intermixing against gravity, it is called diffusion. Clear? How are we getting the molecular mass with the help of this diffusion? We are getting it with the help of Graham's law of diffusion, which states, we are not dealing with the law right now, so I'm just telling what is stated. It states that this: your rate of diffusion of a gas is inversely proportional to the square root of its density. Now density of a gas means what density I am talking about, definitely not the density of that gas. Okay, so this is stated by Graham's law of diffusion. Okay, at constant temperature and pressure, obviously that has to be constant. At constant temperature and pressure, the rate of diffusion of a gas is inversely proportional to the square root of its density. Clear? This was stated by Graham's law of diffusion. Okay, so if R is inverse proportion to root over of 1 by D and we take R1 as, let us take rate of diffusion of gas X, R2 as rate of diffusion of gas Y. You have Graham's law of diffusion in the later part, states of matter. Okay, now if I write R1 by R2, now I know R1 is inverse proportion to 1 by root over of D1 and this is inverse proportion to R2 is proportion to this one. So if I write R1 by R2, then this will go up, right? D2 by D1. Now often this mistake is seen. R1 by R2 equal to root over of D1 by D2. How is this possible? If you do this, you will get the wrong answer. You will get the wrong answer. Okay, so you have to take care. This is inverse proportion. So below will come up, na? It will be D2 divided by D1. Everything under root. Clear? Now this d2 I know, right? Vapor density is twice molecular mass. Vapor density into 2 is molecular mass, right? So instead of this I can write R1 by R2 equal to root over of 2 into d1, 2 into d2 divided by 2 into d1, or you can write instead of this m by 2, then m by 2 into 2 divided by m, it will cut only, no problem is there. I am multiplying 2 both, I can do that, no problem is there, 2 will get cancelled out. So what remains? R1 by R2. Oh, sorry, it will be m 2 into 2 divided by m2 m1, 2 cancel, so it will be equal to root over of m2 by m1. Clear? Understood? Clear or not clear? Here I have put m2 into 2, here I have put 2 into m1. This 2 cancel, this m2 by m1 remains. So this we can use to calculate the molecular mass using diffusion method. Clear? Every time I make this mistake. Anyways, clear or not clear? Understood? So R1 by R2 is equal to root over of m2 by m1. Everything is under root. Make sure you do not make that error. Okay. Next comes ideal gas equation. Ideal gas equation. Okay, what is ideal gas equation? Ideal gas equation is the equation which states this: PV equal to nRT. Make this capital only. Clear? PV equal to nRT. Now we'll say how can we find out the molecular mass using this? Very simple. Acha. This is constant, this is temperature, this is pressure, volume, this is number of moles. We will be using this in the states of matter thousands of times. Anyways, this can be substituted with something. Can you recall? PV equal to, this is what? Given mass divided by molecular mass, right? RT. Can I write like this? How will you find this? PVM divided by RT will give you this mass. This is what we want. Given? Clear? So with the help of ideal gas equation also you can find out this mass. Clear? This is the given mass. That is molecular mass. Then how will you find out? We have to find molecular mass only. Anyways, so what will you do? Here m was there, so here you will not write anything. It will be PV by this m will go down, MRT. This will become m. Clear? Is right though? M will go here. No, this is wrong. Not right. This will be m equal to MRT, and this entire thing will come below PV. Now it is okay. Clear? So W will be, so this m will be equal to WRT by PV. Clear? So you can calculate molecular mass. No problem is there. Okay. Just have to make sure that my like me don't make this type of error. Okay. Then for volatile gases you have another method that is called Victor-Meyer method. What is the method? Victor-Meyer method. Okay. Victor-Meyer method also uses the same formula, W by V equal W by V into 22,400. This formula is used by Victor-Meyer method as well. Okay, here this is mass of substance, this is volume of the vapor form, volume of the vapor at STP, it's formed over there, and this is, you already know what is it. Okay, this is actually coming out from a different point of view. This is coming from a, if you have seen Victor-Meyer's apparatus, then you will get to see there is a outer jacket, Hoffman bottle, small one is over here, Hoffman bottle. Then there is Victor-Meyer tube. The Victor-Meyer tube is going into a inverted type of level funnel where water is there. Inside that volume is vapor is collected. Okay. So derivation is not important. Formula is this: W by V into 22,004. Derivation is a little bit complex, but it's fine. Okay. Clear? So we will be using this method for Victor-Meyer methods calculation, because in Victor-Meyer calculation generally it is direct type of questions, so there are no need of going here and there to find out the answer. Okay, let me check what questions are given in your book regarding this calculation of molecular mass. I just took out the book. Just let me check once. You all are having is Victor-Meyer's method, and see the picture. This is Victor-Meyer's method. Okay, can you see this picture? Let me see this visible in the camera or not. If you can see this, this is the way this thing I was talking about. Here the vapors are formed. So whatever the air is there, that is displaced over here. So this reading can be taken over here. So what is the volume of vapor formed? That will be the air displaced from here. From there we are getting the volume. That is the volume which we are putting in the formula W by V. Clear? Here is the volume. We are getting the volume from here, this portion. Clear? Hoffman's bottle is this small one. This small one is the Hoffman's bottle. Okay, this is the Victor Meyer's tube. Okay, so if you have the book, you can see it from there. Showing it once again. This is the apparatus that we will be using for the Victor Meyer's method of preparation. Here this is the Victor Meyer's tube, this one. This is the thing that we are getting the calculation of V. Weight is already taken before. This Hoffman's bottle that we are having, छोटा बड़ा bottle you can see over here, very छोटा bottle है, तो वो ही है weighting करने के लिए. Okay, that is the W gram we are getting, that is getting from there, and the volume we are getting from there. This clear? Understood from here. This is Hoffman's bottle. Okay, this is the structure that we are going to do. Okay. Okay, fine. Now here, when you are applying this formula, you will be given in the question, like it's given in the question, let's check. In Victor Meyer's method of determination of molecular mass, 0.015 or 0.01015 gram of organic substance displaced 27.96 ml of air at 15 degrees Celsius and 766 ml pressure. Okay, mm pressure. Calculate the molecular mass of substance. Aqueous tension at 15 degrees Celsius is 16 millimeter. Okay. So here you have to check out what you need to do. Let's solve this sum. Achha, what is given in the question? Check. Given in the question is mass is given. Mass is 0.1015 gram. Okay. Displaced how much? That is the volume 27.96 ml. Then it is told temperature and pressure, that is 766 mm, and temperature is 15 degrees Celsius. Always Kelvin is mandatory over here. Okay, 273 plus 15 Kelvin, that is 288 Kelvin. Clear? Understood? This is the given condition. What to do with this? We have another one, that is aqueous tension. That is how much it is given, 16 mm. The aqueous tension at this temperature. Okay, how to solve it? You have to apply combined gas equation. You all know combined gas equation, P1 V1 by T1 equal to P2 V2 by T2. This is a combined gas equation. These are all P1 T1 V1, P1 T1 V1 given. Acha, this is P1, then what is this for? This is not P1. How will you get P1? This is P. P1 is subtract this, then we will get P1. Clear? So when you are applying the formula P1 V1 by T1 equal to P2 V2 by T2, then aqueous tension is to be subtracted. Please keep in mind P1 is this minus this, that is 750. Volume is 27.96. 27.96 divided by temperature 1 is how much? This 288. Now what is pressure 2? STP conditions. Pressure 2 is STP condition. Okay, how much is this? 760. Volume 2 is how much? How much is the volume 2? Do we know the volume 2? We are finding the volume 2 only, right? Then volume 2 is V2, this is 273. Clear? Now perform the calculation. Hold on your calculators and perform the calculation, because without calculation, you cannot do this calculation. Okay, how much is this coming? 750 into 27.96 divided by 288, 72.815, 72.81, 72. Are you sure? 72.81. 750 into 27.96 divided by 288, 72.81. Okay, 72.81 into 273, that is 19877. Acha, divided by 760. Okay, so V2 has come 26.15 ml. Okay, this is V2. V2 we have got as 26.15 ml. After calculation, we have got it as this. Okay. Okay. Now this volume is the amount of vapor formed, right? This volume is the amount of vapor formed. So amount of vapor formed is equal to the amount of air displaced. Vapor formed तो air displaced, air को displace करके तो vapor होगा ना, कहाँ से आएगा? ठीक है, तो जितना वेपर फॉर्म हुआ उतना एयर डिस्प्लेस्ड हुआ. समझ में आया? तो ये रहा आपका इक्वेशन, मिल गया आपको. अभी सॉल्व करो इसको. 26.16 ml का वेट कितना है बेटा? ये गिवन है क्वेश्चन में, गिवन है क्वेश्चन में. तो इसको इरेज करते हैं, लेट्स डू इट. हाँ, तो आपका जो आंसर आया था 26.15 ml, उसका वजन है 0.1015. तो 22400. वेट विल बी हाउ मच? कैलकुलेट इट एंड दैट्स द आंसर. कैलकुलेट. 10 लिख दिया. 0.1015 divided by 26.15, 3.88 into the power 3.88 to the power minus 3. 3.88 into 10 to the power minus 3. अच्छा, इसको करने पे ये आया 22,400. कितना आ रहा है? हाँ ठीक है, 86.9 नहीं सॉरी 912 ग्राम, यानी 86.9 ग्राम. ठीक है, 86.9 ग्राम. समझ में आया? What is the answer? 86.9 gram. Clear? So in the case of this Victor Meyer method, you will be given with the aqueous tension of some pressure that has to be subtracted from the main pressure, and then you will be taking out how much vapor is formed. That will be the air displaced. Then accordingly we will be putting in the values of this and we will be writing, and we will be getting the proper answer. This is the molecular mass of that organic substance that was taken. Clear? So that is all we had to do today. In today's video, we have covered all the weight portion. In the next video, we will start with the volumetric analysis. Okay, so see you in the next video. And also this is the last video of this year. To be honest, it's the last video, 31st of December. So let's again come with a fresh start from next year. Happy New Year in advance to everyone. Thank you.